Okay, so today I'll be presenting on some work in progress on data sharing and citations, where we're looking for causal evidence. So this is joint work with Alan Defoe, who's in the political science department at Yale, and with Ted Miguel, who you probably know. So thank you to David Birka and all our many undergraduate research assistants on this project, because this project involves a lot of painstaking data collection, so it wouldn't happen without them. So this follows nicely with what you just saw in terms of the concerns about data sharing. Well, we're looking for incentives, or sort of the positive reasons for data sharing. Sort of the problem is that shared data is a public good. This is the idea that you don't capture the full value of the thing you provide, like vaccines, so they typically end up being underprovided or undersupplied. So, but if you actually do get, if there is private incentive that you the reward of which you reap, then people do that behavior in adequate amounts. So if there is a private incentive to sharing data, then people will share data. So maybe in some utopian future society, people who share data will be rewarded with promotion and tenure, but in our current actual real world, maybe they'll be rewarded with more citations. So our question is, do you get cited more if you share your data? Why might you be cited more if you share your data? It might be a signal of quality. If people are willing to share the data, then they aren't secretly worried about the fact that their results are very flimsy. I mean, maybe that's tentative, but really I think, almost mechanically, it facilitates the ability of other researchers to build off your work. People are just sort of thinking, oh, what do I want to do research on? Well, that's a function of what data is available. So I see that this data is available on this website. Sure, I can come up with a question about that data set and write that. And so you facilitate other researchers building off your work and thus citing you. So one just clearly anecdotal example, Josh Angrist is a well-known economist. This is his webpage, and these are the data sets for all of his papers. And if you look at his Google Scholar page, the top result for him is a book that's been cited 8,000 times, and then a paper that's been cited 4,000 times. So he's well cited. It's not causal, but it's just most MIT economist professors actually have web pages and citation pages that look like this too. But so what's the systematic existing evidence? So Heather Pivovar has a couple papers where she's looked at biology, cancer, genetics data sets, and found positive associations between data sharing and citations. So a small sample size, so only n equals 85, but 69% more citations in some cancer work. And then much larger sample, 10,000 articles, found a 9% increase in citations. And some work in the Journal of Peace Research wrote the article, "Will you be scooped or will you be famous?" Their answer was, you'll be famous. There was a response that kind of disagreed and said it was only like really at the top in the most cited papers, but a follow-up using longer data period said, no, you really will be famous. But this is this is a figure from one of Pivovar's papers. The blue distribution you can see is shifted to the right. That's the papers that shared their data. And again, the blue distribution, this is from the Journal of Peace Research. That's the distribution of the papers that shared their data. But this is all correlations. and we're interested in causality. So our idea is to exploit plausibly exogenous variation in data availability caused by the abrupt change in editorial policy at a top political science journal, namely the American Journal of Political Science. So Rick Wilson became the editor January 1st, 2010, and he said, if a manuscript is accepted for publication, it will not be published until the first footnote, unless the first footnote explicitly notes where the data used in the study can be obtained for purposes of replication, and should note any sources that funded the research. So that's in 2010. That gets implemented, and then they kind of realize, oh, we're not really enforcing this hard enough. So a year and a half later, in 2012, they started mandating that the data, not only that you had to have a footnote saying where it is, no, it has to be in Harvard's Dataverse. So Dataverse has very easy for any organization that wants to carve out a corner of Dataverse, including journals like this. They create their own little corner, branded corner of it, and to be published in AJPS, you have to put your data there. And so July 2012, that was implemented. And during this whole period, this whole time, there's no policy implemented at what our control journal is, the American Political Science Review. So these have been #1 and #2 in political science for decades, and the #2 journal changes the policy. The #1 journal does not change the policy. So we're in progress on getting data for economics, and the sort of the background to the journals in economics, it was slightly earlier, it was 2005. So 1986, there's a paper called the Journal of Money, Credit, and Banking Project that embarrassed economics in general by showing that verification, even just simple reproducing using the same data and the same code, couldn't get you the published answers. Not a lot changed until another paper provided another embarrassment, saying if you use the same code on different computers to solve with nonlinear methods, so you have to using numerical methods, you get different answers on different computers. So we should be aware, we should think about that at least. So Ben Bernanke made data sharing mandatory for the American Economic Review, which is the flagship journal in economics. That kicked in 2005. Just for comparison, Quarterly Journal of Economics instituted a policy, but only in 2016. So Alan came up with this identification strategy, and so we have a pre-analysis plan. This is observational work, but it takes us a long time to collect this data. So before we collected any data, we have a little pre-analysis plan. And our pre-analysis plan describes that we're going to use two-stage least squares to estimate a local average treatment effect. For the non-economists in the room, I will try and explain this method, which this is our standard regression equation. We're regressing y on x. The problem is x is endogenous. So there's reverse causality, or there's an omitted variable. There's omitted variable bias. So some unobservable characteristic, namely, let's say quality. So if we just regress citations on data availability, there might be the omitted variable bias of quality, because lower quality paper authors inherently know the quality of their article, and then they're like, I don't actually want to share this data. So then it's a worse paper, but it gets cited less because it's a worse paper, not because of the data being available. So we need an instrument, which is some lever or some policy that changes the changes the availability, the data availability, without also changing the outcome of interest, which is citations. So if we find some variable z that's correlated with, that's uncorrelated with the error term, but is correlated with the policy of interest. And statistically speaking, instrumental variables is biased but consistent, so we need a large sample size. How you implement this is to predict x with your instrument. So you predict, and we do that, we predict data availability with the instrument, which is in our case is the journal policy. Then you regress the outcome, which is citations, on the predicted availability. And so this predicted availability is stripped of the endogeneity problem. This assumptions that are required are that your instrument actually does a good, strong job of predicting the x of interest. So this is called the relevance assumption, and so the x, meaning the journal policy, has to do a good job of predicting data availability. And we usually, the cutoff is an F statistic greater than 10. And the exclusion restriction, which you sort of have to tell a story about because this is not fundamentally perfectly testable, but it's that the instrument, so in our case, the journal policy, only affects the outcome, citations, through the included x's. So the data policy didn't change quality at the journal. And there are some ways to test that I'll get into in a minute. So examples, probably the best examples are the top two there, where there's some sort of randomization. And so if you're a medical trialist and you're doing a medical trial and you have incomplete adoption, well, there's the treatment assignment is usually a good instrument for whether you took the treatment. It's not perfect because not everybody takes the treatment, but you can use this IV or two-stage least squares to get an estimate of the treatment on the treated versus the intention to treat. Economists have used this in lots of ways. An interesting one I think everybody believes is a good example of instrumental variables is the Vietnam draft lottery. So they randomly pick a number using like literal random ping pong balls with birth dates on them, and then that assigns your likelihood of getting drafted. And it's not a one-to-one correspondence, but there's a random instrument, random truly exogenous variation in birthdays that assigns your likelihood of getting drafted into the Vietnam War. So that's our strategy. So what we do is the top is how we predict availability. So we're just predicting availability of data with whether it was an article in American Journal of Political Science, whether it was after 2010 or after 2012, because there's this 2 stages of implementation of the policy, and then the interaction of those two, and we control for the time since publication. I should clarify those last G and H terms. We just control for time since publication. And so then we then regress citations, count citations on predicted availability here. So predict availability and then regress citations on predicted availability. So what do we see? So first of all, some summary statistics about this. We find citations are highly concentrated. I don't think this is a surprise, but it's probably a surprise how concentrated they are. Citations increase over time. That's mechanical. And citations are indeed affected by the journal policy. So what do we see? Sadly, for most of us, I guess, most papers are cited 0 times. So, so we should probably, we actually take the log of citations plus 1. So there might be some distributional things that we need to think more about. I'd be happy to take comments on. But this is the distribution of citations, and this is just grouping all articles by year and showing at the point in time that we collected this data, which was sometime during this year, and showing citations. And obviously, so this is, yeah, newer articles have been cited fewer times. I don't think that's surprising. But you see pretty similar number of citations in these two journals that we're using. And this sort of shows, yeah, the policy made a difference. So 2010, so this is the fraction of journals which share their, of articles which share their data. And 2012 especially, there's a big jump in AJPS, which had this policy and strengthened it then. So statistical results, I'll show you this naive OLS results, was it's just regressing citations on whether data is available. Our first stage is second stage and tests of the exclusion restriction. So this is the naive OLS result, which is, so this is just a correlation between citations and is your data available. So we regress citations on whether the data encode is available, whether it's in the AJPS, a cubic function for months since it's been published, and in some specifications, whether it's a whether the article has any data, because political science has theory articles, and so they're talking about John Locke and how great he was, and there's no data in it, and so those papers suffer citation-wise. But and so here in our this fourth column is sort of our preferred specification, where we're really simplifying by looking only at the articles that have data. Great if you want to be a theorist with no data, but that's, you know, that you're not going to be affected by the policy about data sharing. So in this last one, you can see 11 more citations for articles that have shared their data. And then, so this is just to make the numbers larger. I just cut out the terms there. They're still included. This is the same result. So 11 more citations just for the people in the back to be able to see this. So 11 more citations. What is that in percent? Well, in log points, so you can roughly interpret that as a percentage. It's 28 log points, 30% increase in citations, which is a lot. So 11 citations. Since most papers get cited 0 times, 11 extra citations is a lot, and a 30% increase is a lot. So, but that's just the pure association. So now a statistical test of whether our empirical method is valid. We run, so these are the two, our indicators of the policy. So these are, is it an AJPS article after these two policies? The outcome here is data availability. So yeah, there's a strong, significant increase in likelihood of availability if you published in that journal after the policy came out. So, and I said that like a rule of thumb that economists use here is whether that F statistic is greater than 10. We've got 24 to 33. So yeah, so this is a strong instrument. This policy does a pretty good job of predicting availability. So what do we see, though, in the actual test? We see that we are underpowered. So because of how noisy the distribution of citations is, we just get massive standard errors there compared to our estimates. So this row is what we're reading here. So this here is our best estimate of a causal impact of data availability on citations. In terms of a linear count, this goes from just the point estimate goes from 11 down to 4, and it's very imprecisely estimated. So that's given the audience, I wouldn't, like, if it were a null result, I'm not poo-pooing it because it's a null result. It's just very imprecisely estimated. So and what do we see in terms of percentage? So this is where the two-stage regression, where the outcome is log of citations plus 1. So 12, 13%. Again, positive estimate, but again, very wide confidence interval. So not really clear if this is causal. And so that's sort of our main takeaway there. But one side effect of doing this project is that you learn how interesting citations are in and of themselves, especially to our librarian friends here in the front. So there are multiple sources for citations. They're definitely not open as far as I have found yet. There's an initiative to change that, the Initiative for Open Citations. The results are very robust to our source of citation data. I think what a lot of people think of these days is Google Scholar, but that's a very black box and is totally unscrapable. So they won't tell you what sources they're using, and it's like totally impossible to automate collection from there. But if you have a library with enough money and can use the API from Scopus and Web of Knowledge, so we've used both of these APIs to systematically collect these citations, and there's a pretty, at least these two sources collect what I think is, it's not widely varying across these two sources of data. So pretty high R² there in terms of the correlation between Scopus and Web of Knowledge citations. And so lastly, I will mention, so this is an investigation of whether our method is valid, whether the exclusion restriction holds. So I said the exclusion restriction is the idea that the change in journal policy only changes citations through data availability. So if other things like article topic or article type or author quality, author institution ranking, any of those things that you could imagine, if those changed with the policy, then our method is maybe not so valid. So here I have graphically for the 2010 and the 2012 policy, just got, we classified every article in these journals into groups, whether it's American politics, international relations, theory, comparative, or methodology. And you can see, so here's APSR before and after the 2012 policy, and AJPS before and after the 2012 policy. And the distribution of article topics doesn't appear to change significantly with the policy. Then we looked at the data type of the article. So we classified, does this article use experimental data? Primarily, does it primarily use experimental data, observational data, no data, or is it pure simulations? And there is some noticeable increase in experimental data, because development economists and political scientists were realizing, like at about this time, like, hey, we can and maybe should run some randomized trials if we're interested in causal evidence. So that did change, but we can you know, it's not, that probably wasn't changing because of the policy, and we can test this statistically. So the last thing that we've also gathered data on to test this is just the institutional ranking of the author. So across all authors, we link authors to their institution, and we use just US News and World Report rankings, and we see whether we take the top US News and World Report ranking of the institution of any of the authors. And so you can see the distribution, again, distribution broken down by ranking before and after. There seems to be some shift here, but it's not huge, and we'll test this statistically with this test. So this is just to test the this runs the same specification, so the same instrumental variable specification on, we test the outcome of, is the article American politics? Is the article methodology? Is it experimental, observational? Is it top 5, these distribution? That's the outcome, and then you regress on whether that's before and after the journal in the policy, before and after the policy in the journal. And out of the 12 coefficients here of these that I've tested, 2 of them are significant at the 10% level, which is about what you'd expect due to chance. So we find that there's not much going on. These as far as article topic and article type and author ranking, author institution ranking, those observable characteristics of the article are not changing with the policy. So maybe our empirical strategy is valid. So what do we conclude? We conclude that top political science papers with public data are indeed cited more, but there is not strong evidence of causality. And journal policy does not appear to have changed submissions. So the strategy itself is okay. So in the future, in the present, we are still collecting data from American Economic Review and Quarterly Journal of Economics. The AER publishes a lot of articles. But thankfully, there's JEL codes. Political science articles are not broken into like discrete categories, but economics, thank goodness, does have these codes. So it'll be hopefully easier to qualify some characteristics of them. And we're collaborating with Don Moore and Andrew Rose to expand our journals, because they've found in this top 250 journals that there are 19 that have had policy changes, so that you can get data before and after and on citations. But so that we can finish this project in our lifetimes, we will sort of limit the data collection, and we'll be able to use the econ and poli-sci as a more in-depth look, but also check if these patterns are possibly holding across disciplines in a much wider sample of journals. So that is all. Questions? Back there, but.
Thanks. So you talked about mostly about changes in kind of author composition in thinking about what kinds of quality articles come in. I think a couple of other sort of plausible stories are paper-specific changes in composition. So authors who kind of have a paper that they know is either going to stand up to the test of time after their data is published, or they know it isn't, and they might be thinking in this narrow window that they have the selection between these 2 top journals that they'll select into one or the other of those. And then secondly, I just wonder whether editors who implement this policy or fail to implement this policy in that time might have different ability or interest in selecting high-quality research, and so that might drive a set of composition effects that are kind of hard to measure here, because what you're really talking about is And then kind of a question for you. I was curious about the proportion of papers post-policy that you weren't able to download. There's a strong effect on the policy you showed. I was curious about the proportion and just kind of what happens when those, there's been a range of these kinds of policies that range from posting in replication archives and checking. This is one of the weakest ones. So I was kind of curious what happens. You have to have this footnote, but then are they not? Are the links broken? Or yeah.
Yes. So excellent on the first two suggestions. I totally agree with you. I mean, that's the limitation of our method is that we can test those observable channels like institution ranking, but it's impossible to test all the unobservable channels. So, and I agree that measuring, the inherent paper quality, that's very hard to test. So, and then your second point as availability. So and why this data gathering is so difficult is that we sort of, we tried to think of every source that counts to us as available. That means the internet, but the internet is big. So that's the journal website and then Dataverse, but not just that corner of Dataverse, so all of Dataverse, and then any mention, like a link to it on the author's webpage. And so we searched for authors' web pages, and then through the text of so we have keywords in the text of every article, and then we flag every one of those keywords and then look as to whether that is a reference to the data, and if it's a link, we follow up on that link. And so because of that painstaking process, we have data on sort of partial availability, and we have separate data on code and data, and we haven't analyzed that yet. And we also might be able to do something because I don't quite think that we'd be able to look at, whether a link existed once and was, and is now 404, but this is basically, our measure of availability is whether it's available on the internet in the last year when we looked at it. So.
Can I just follow up on Grant's point?
Yeah.
One thing that we can do to get at the editor effects is there was a period of time, both for Ben Bernanke and then for Rick Wilson, before they implemented the policy. So I think at least in theory, we could have editor fixed effects. Of course, the problem here is we're so underpowered statistically that by narrowing the window even further around the policy change, it's just going to hurt us even more. But at least conceptually, we could address it. And as Garret said, the AER and QJ have a lot of articles, so the standard errors are going to be falling. And then we've joined forces with Don, who has a lot more journals in play. So the hope is we will have enough power, and maybe if we do, then we could do things like editor fixed effects precisely for that reason.
So it seems like there's a qualitative difference between having 0 citations and 1 citation on a paper. I don't know if, and it makes me think that the mechanisms and the implications of these results are different if it's driving small and relatively unnoticed papers to get some notice, or whether or not it's a nice to have on already relatively famous papers that are going from 100 to 130 citations. I guess my two questions are: one, like, what is the mechanism that you are imagining, and does it hold the same for the papers on either side of this PDF? And is it something that you could look at, the difference between, like, increasing on the extensive margin versus the intensive margin of widely cited papers?
Well, so the mechanism, I think, is, more just the data is available, and thus it's easier for people to do research with that data, as more than more so that than a signal quality. But I mean, I'm more than happy to look into that. And I mean, if there's statistical things that we should be doing because of this skewed distribution, then I'm all ears. But with the caveat that we didn't pre-specify that we would look sort of for heterogeneous treatment effects, I'm happy to do that. Because this could be, like, it's an interesting question whether this is getting some notice for, the grad student who put his or her paper on data online, or whether it's Josh Angrist getting the 9,000th citation instead of one more question? Happy to go to lunch too. Thanks.